This is the recording for the Unit 5 homework quiz. So the first one, of course, is that you did all these. I believe actually in this one there is actually no mechanical universe, but just say yes. The question 2 here, you're familiar with that by now, so you choose one of the exercise questions or whatever they're called, type it in, answer it. Okay, the concepts in contents and objectives, so check it out in the book. I think all of these apply, so define density, apply Hooke's law, classify tension and compression, and so on. And you can also check where I have them listed at the beginning of the unit in Blackboard. These here, check the worked out problems in physics. I'm just going to give a couple of away. Of course, when you see density 17.7 here, it probably matches up with grams per cubic centimeter. Down here you have another density, so that would be recycled, of course, or used again. Here you have pressure 2.2 million, and that ought to be in the metric unit, which is the Pascal. Here you have a stretch of delta x equals 10, so that's centimeters or meters. So look it up. Side length, same thing, centimeters or meters. So look up the problem in there. Force, more likely than not, the 1.96 here is the newtons and so on. But look up the problems and work through the problems as well. That's the idea. All right, these here are think and do problems from the book. So in the 11th edition, these are called projects. In the 12th edition, these are called think and do, but they're the same. And then there are very long explanations that I wrote in here. So look at this one here, look at my explanation. And I think the way I posted them is that they're backwards alternating. So this here would be B, A, D, C, F, E. I'm pretty sure. Look at the explanations and see how they line up with the projects. These are from the video, so from the fluid experiments that you can watch on YouTube, and I believe for the most part they're also kind of like the last one, so it's like B, A, D, C, F, E. So for example, paperclip floating on water. The surface tension of water counteracting its weight keeps it afloat. Soap, on the other hand, destroys the surface tension. Capillary tubes. Adhesion and surface tension counteract the weight of the water column. For a partial explanation, see the hyperphysics link here, and you will see, well, they talk about capillary tubes there. The lung model. Now that there is a larger volume in lungs, there is now less pressure. Hence, the now comparably larger pressure pushes air in, inflating that volume. Holds at different levels, larger hydrostatic pressure pushes water out at higher speed. There you go. So as I said, kind of flip there. Until you get to this one here, candle in a water pan, that actually is this one here. Fuel molecules remain in the air and so on and so on. You can read through this yourself. Then connected soap bubbles for smaller radius. It turns out that the inside pressure is larger in a smaller soap bubble, pushing the air from the smaller soap bubble to the larger one. And again, there's a partial explanation in hyperphysics in this link here. Cartesian diver, the pressure of air is increased by pressing on the bottle, more water is thus pushed inside. But you would have to watch the video that I made in order to make sense of these kinds of experiments. Connected syringes, I actually described that in the practice test in midair, but again, look at the video. While the pressure on this is the same on either end, the forces are different because the two syringes are of different sizes. All right, question 7, that's the extra book, how everything works. Vacuum cleaners, by the way, I did fix that spelling error in the meantime. And so read through it, and top of my head I figure, well, their Venturi effect is going to be in there. Pressure, partial vacuum, probably air accelerates from higher pressure toward lower pressure. Probably not the Doppler effect. but read through that in that book and answer this question. And that's actually the recording for the Unit 5 homework.